everyone. This is our 13th lecture of our first lesson, relation and functions. In previous classes we have already discussed type of relations, then type of functions also. We have already discussed which type of relations: reflexive, symmetric, transitive, equivalence relation, and another thing that empty relation and universal. In functions we already discussed injective function, surjective and bijective, means one function, onto function, many one and into. Okay. Now in this class we are discussing composite function. Now what is composite function? I think we have just introduction we have taken in our last class. So just revise it once and we start composition of a function. Suppose I take A, this is B, and now third I have taken C. I show you one function, this is your f, A to B. Another function we are taking G, that is B to C. Now which example we have considered? That suppose this is your roll numbers. I have taken first 5 roll numbers of our class. So roll number 1, 2, 3, 4 and 5. Okay. Now I have taken name of them, A, B, C, D and suppose E. So with 1 I have taken A, with B 2, with C 3, D and E, that way. Now this is our first function f. Now if in exam A get out of 20 15 marks, B get 16 marks, C get 19 marks, D get 20 marks and E get 10 marks. So what I assign? That first with student roll number and with roll number your marks. So if I want to know only roll number and marks, then I have to combine this function and that is your G over F. Okay, what is your G over F function? Means we have combined F A to B function, G B to C function, right? So now what is your G over F? G over F is A to C. We have combined this function. So this is called the composition of a function. Okay, so how can we write this composition of a functions? I can write G over F of x. That means G of fx. Now in x, which in f, what is the domain of f? That element you can write here. So if I write first element 1, so with 1 which number is assigned? A. With 2 B. This way we have assigned all this name and roll numbers. So when I write f of 1, what I have to write for f of 1? The assigned number is A. Now G of A, with A, what is assigned in G? 15, with B 16, with C 19, with D 20 and 10. So I can write on place of A, GA is 15. So what is the meaning of it? That first one get 15 marks, roll number 1 get 15 marks, that is your G over F. So I have already explained these things. Definition in our previous class. We have taken one example. So this is your composition of a function. Okay, same way let's take another example, G over F of 2. I have taken second. So G of F of 2. Now what is your F of 2? Here B. So we can write G of B. Now what is your G of B? That is 16. What is the meaning of it? Now another order pair you get, that is 2 comma 16. First order pair we get, that is 1 comma 15. Means roll number 1 it's 15 marks, that is your composite function. Roll number 2 it's 16 marks, that is your second order pair. Same way 3 comma 19, 4 comma 20 and 5 comma 10. That is your G over F. Now I think composite function is more clear to you. So we start its example of a composite function. You can open your textbook and in your textbook first solve sum, read it. our first question, what is your 15th number? First question is given, solve question 15. Function is given f 2, 3, 4 and 5, 2. 3, 4, 5 and 9. Another function g is given, that is 3, 4, 5 and 9, 2, 7, 11 and 15. B, the function defined as f of 2 equal to 3, f of 2 equal to 3, f of 3 equal to 4, f of 4 and f of 5, both are 5. And another thing is given, that is g of 3 and g of 4 is 7 and g of 5 and g of 9, both are 11. Now you have to find g over f. Now first, when we are going to find g over f, then what to do? We have to check first f. What is your f function? So we have to start first number with 2. So when I start g of fx, what is the meaning of it? G of f of 2. Now what is your f of 2? That is 3. So g we can write g of 3. Now check here, what is your g of 3? 7. So your answer for g of 3 is 7. So what you get as an order pair? First is 2, 7. That is your element for g over f. Now let's come to the another element 3. So how can you write g over f of 3? That means g of, what is your f of 3? 4. So we will write on place of it 4. Now what is your g of 4? So check here, g of 4 is 7. So another order pair is 3, 7. Now check for 4. For 4, f of 4 is 5 and g of 5 is 11. So what is your next order pair? 4, 11. And last element 5. So for f of 5, 5. And for g of 5, what do you get? 11 only. So 5, 11. Sorry, for 4, 7 is there. Clear? So that way you get all order pair. What is the meaning of it? The aim is this only, that g of fx means g of, first you have to choose element of f. So first we have choose 2. So when you choose 2, you get 3 as an answer. So now you have to check in g, what is 3? So g of 3 is 7. So first order pair you get, that is your 2, 7. Come on, same way check second, f of 3. So when you check 3, your f of 3 is 4. So check here. So what is your for 3? F of g of 4 is 7. Now check 4. F of 4. Now for 4, what is your f of 4? 5. So for g of 5, what do you get? 11. Now next is 5. So now when you choose 5, f of 5 is 5 and g of 5 is again 11. So that way for 4 elements you get the order pair. Okay, which number you have to choose? Domain of f means 2, 3, 4 and 5. So we have taken 2, 3, 4 and 5. For that your answer must lies in g's codomain, means your answer should be for g's term. So we get 7, 7 and 11, and 7 and 11 both are in the codomain of g also. So what is our condition? That range of f is a subset of domain of g, that is that range of f is 3, 4, 5, 9 and domain of g is 3, 4, 5, 9. So both are equal. What is our condition? That it should be subset, but we get the same. So that way you get g over f. So this is your first question, how to find g over f, 15 number. Now come to the next question, 16. Read in your textbook, what is your 16th question? Question number 16 is function for, you have to find f over g, g over f, and function is mentioned from R to R. g also from R to R and f also from R to R. And fx is given cos x and gx is given 3x square. Okay, and you have to prove it, both are not same. Okay, let's start with first g over f. How can we write g over f of x? So we can write g of fx. Now check, what is your fx? It is cos x. So we can write on place of fx which function is given, that you have to write. So cos x. Now remember, in gx on place of x, what you have to write? Cos x. So here gx is 3x square. On place of x we can write cos x. So your answer is 3 cos square x. This is your g over f. Now let's find f over g. F over g of x. So f of gx. So what is your gx here? 3x square. So we have to write directly 3x square. Now what is your x? 3x square is your x for fx, and on place of x you have to write 3x square. So what you get? Your f over g, g over f. F over g is cos of 3x square and g over f is 3 cos square x. Both are not same. So what you can write? F over g of x is not equal to g over f of x. Okay, let's repeat it once. What you have to find? G over f. So first we have written g into f over fx. So on place of fx, what is function is given? Cos x. So we have written on place of it cos x. Okay, now cos x is your x and you have to write in fx. So in fx, cos x is written. Now on place of this x, what is your gx? 3x square. So in 3x square, on place of x, we have written cos x. So 3 into cos x square. So 3 cos square x, that is your g over f. Now f over g, again same. F of gx, on place of gx 3x square is written. Now consider it as an x and write in fx. So in cos x, on place of x, we have written 3x square. So now f over g is your cos 3x square and g over f is 3 cos square x. Both are different. So what we have to prove? That f over g and g over f both are not same. That is proved. Now come to the next question. Question number 17. In 17 question, function is mentioned from f r minus 7 by 5 to r minus 3 by 5 and fx is defined as 3x plus 4 upon 5x minus 7 and gx is defined again same way 7x plus 4 upon 5x minus 3. You have to check that f over g, g over f both is identity, where what is your a and b is given and identity of x is called identity function, that we already know. So fx and gx is given. You have to find f over g and g over f. First let's start with f over g. So f of gx we can write. Now let's start with gx. What is your gx? This function means 7x plus 4 upon 5x minus 3. Okay, now you have to consider this as an x and you have to write in fx. So how can we write? 3 into what is our function? That is your x. You use this as an x. So I have just changed the color to make you more clear. Same way. Again function is same, everything is same, but on place of x we are writing only 7x plus 4 upon 5x minus 3. So is it clear? Now one simple thing, take LCM and simplify the term. Okay, let's take LCM. 7x plus 4 with 3 plus 4 into 5x minus 3. Now check, denominator is same in both, so we cancel it. 5 into 7x plus 4 minus 7 into 5x minus 3. So now just open this bracket, 7 3s are 21x, 3 4s are 12, 4 5s are 20x and 4 3s are 12. Similar way, 5 3s are, 7 5s are, 5 4s are, again 7 5s are 35 and minus minus plus 21. Now here check, plus or minus 12 cancel and here plus or minus 35 cancel. 21 and 20, that is 41x. Same way 21 and 20, 41. So what you get? X. Means we get f over g of x equal to x. That is called identity. Clear? So first I have shown that is how to find f over g. Okay, let's repeat it. So first fx is given this, gx is given this one. Now what you have to find? F over g first. So f of gx. On place of gx I have written this function. Now in fx you have to consider this as an x. So in 3x plus 4 and 5x minus 7 on place of x I have written this function. Okay, now what simple thing? Take LCM. Denominator is same in both, so we have already cancelled. Now LCM is taken. Open your brackets. What is the common term? 41 41. So we have cancelled it and remaining is x. So what we have proved? F over g is identity. Identity means f over g equal to, we are getting x. Now g over f, the same question, but now we have to find g over f. Now let's find g over f, means g of fx. Now here you have to write fx here. So g of 3x plus 4 upon 5x minus 7. Everything is same how we have find in f over g. Now let's start in gx. On place of x we have to write this function. Right? So what is it? Our question is this. So 3x plus 4 upon 5x minus 7 and gx is 7x plus 4 and 5x minus 3. So again we have written in the same manner, right? Now next step is LCM. So take LCM. What is it? 7 into 3x plus 4 plus 4 into 5x minus 7. Denominator is again same. So cancelled it. 3x plus 4 minus 3 into 5x minus 7. Okay, open this bracket. 7 3s are 21, 7 4s are 28, 5 4s are 20 and 7 4s are upon 5 3s are 15x, 5 4s are 20, 5 3s are 15x and minus minus plus 21. Now check. 28 28 here same, here 15 15. 21 and 20 41x. Same way here also 41 41 41 cancel x. What you get again? G over f of x equal to x. So you can write g over f of x equal to x and that is your identity function. So what we have proved? That f over g, g over f both is same and both is identity function in this question. So I think today we stop here and in next class we continue with our 18 question. Thank you.